Okay, so if we're talking about the changes in A, the first one we want to start with is your parent function. So, what I want you to do in your calculator, I want you to see what this looks like. So everybody go to your calculator. And I'm going to clear mine, so I'll start the same place you are. Go to our y equals. We want x squared. Basic x squared. Nothing added to it. 1 in front of x squared. And graph. Looks different than what we've been doing. Maybe because it's a parabola. Think about what it means with x squared. It means that every number you pick for x.
I can have Jermaine Blue Ellen to come to front office for a moment.
Yes, ma'am.
Thank you.
Every point that you have here, you're squaring it. So if we looked at a table, notice up here whether we have positives or negatives. Negative 4 squared, negative 3 squared, negative 2 squared. We've talked about that means the negative times negative. 1 squared, 2 squared. So notice how these are repeating. You have a beginning point. We're going to call this beginning point our vertex. Your vertex can be a minimum on your graph, can be a maximum on your graph. The vertex is where you start, just like our y-intercept was, and then we're going to go to either side of that for your parabola. So when we look at our paper here, we have a function that's simply y equals x squared. Our first column here with our vertex is simply going to be starting at 0, 0. Because you're not adding or subtracting anything. It's not shifting off of that center point. So if we look at our table, I'm actually going to put 0, 0 in the center here. The reason is because it's not just a straight line. It goes on either side of this point. So if we have negative 1 for x, negative 1 squared is 1. We have negative 2. Negative 2 squared is 4. And I can do the positives. And then let's plot our points over here. Should look like what you have on your calculator. So then we have our 1, 1, and we have our 2, 4. So this is your basic form of your parabola. And we don't have any effect on our parent function here because we didn't do anything to it. It is the parent function. So when I ask you for the parent function of a quadratic, this is what you're looking for. Y equals x squared. Starts at 0, 0. Has even your integers squared on either side. Okay, so we want to know, since our general form is ax squared, on this first side we want to look at what's happening if you change a. We've got several situations here. We have whether it's positive, whether it's a fraction, positive integer, positive fraction, or if you have negative. Okay, well think about this. We have 2. We can compare these really easily in your calculator. This is what I would do when you're comparing. We did this with linear also. Make your original, go over to the left side, make that one darker. Leave it in your calculator, but make it darker. Because we want to keep that one. And this is our starting point every time. And let's go down to y2. Let's say what's going to happen if we make this a 2. 2x squared. Go to the far left side of your graph. If I graph this, what happened to your line?
You got bigger. Eliminate the first one or the second one?
The first one is your parent function. What is the change to this one? It's steeper, and in the case of a parabola, since it went closer to the y-axis, it's more narrow. So we use the word steeper when we're talking about linear. We want to talk about more narrow when we're talking about parabolas. So, we say here, what's the effect on the parent function?
Steeper.
It's more narrow. That's in general what's happening. It's more narrow. And you can quickly see that by comparing it to your calculator. But we don't want to just depend on the calculator. You want to have a little bit more detail in there. Well, did it change where it started? No, there's no addition, subtraction to it. We still have starting point at 0, 0. So I'm still going to look at this point. None of that's changed. But if we go to 1, what are we going to get right here? X is 1. 2. Because 1 squared is 1 times 2 is 2. If we have 2, we have 2 squared is 4 times 2 is 8. So we get big really fast. The negative, because it's a parabola, should do the same thing. Just be very careful that when you put these in the calculator, if you're checking it, that you put that negative in parentheses. That's why we did the study on the exponents first. So this one should be a steeper or more narrow line. It's going up faster. So that A in the front kind of works like slope. It does mean that it increases faster. But in the terms of parabola, we're going to say it makes it more narrow. Okay, so what about 1/4 x squared? Do you think it's going to change where you start? No, because we still aren't adding or subtracting anything. This is still going to be 0, 0. But before we look at the graph, let's think about it. If you have 1, 1 squared is 1. What's 1 times 1/4? 1/4, 0.25. Okay, you can do either one, 0.25 or 1/4. Okay, so that's not going up very much. What about if we have 2? 2 squared is 4. What's 4 times 1/4? Yeah. No, 4 times 1/4. 1. 1. So if we go the other way, negative 1 is at 0.25, and negative 2 is at 1. So think about our graph here. At 1, we didn't go up very high. At 2, we didn't go up very high. I know this is not exact because these are really short, squished up graphs. But what happens to your graph? It's wider because it's going up slowly, more slowly than the other one. So this is wider. I can look at this on my calculator. I'm going to keep y equals x squared, but I'm going to change this to 1/4 x squared. And look at it. There's my original. And there's the second. Okay, so we can see a comparison that it should make it wider or it should make it more narrow. What do you think is going to happen with y equals negative 3x squared? Okay, it's going to be going the other way. It's still going to be crossing at 0, 0. We didn't add or subtract anything. But this time, if I have 1 squared is 1, times negative 3 is negative 3. And so this one is going to be down here. Same thing for negative 1. It's going to be negative 1 squared is 1, times negative 3 is negative 3. And so this one's going to be going down this way. 2 squared is 4 times negative 3. It's going to get big really quick. And so it's going to be going like this. So we kind of have two things with this one. Is it 12? Yes, because 2 squared is 4 times 3, 12. So this one is open, down. And is it, compared to the parent function, is it wider or more narrow?
No.
It's more narrow because it's 3. So this one has two changes. It is more narrow because it's a 3, and it opens down because of the negative. So those are our basic changes to our parent function. Okay, so turn down to the back, that second page.